Now, enhanced oil recovery is a big issue in the States. They believe that they could recover an additional 240 billion barrels of oil by injecting CO2 into oil reservoirs. So to put the number of 240 billion barrels of oil into perspective, the US has undeveloped oil reserves of only about 1 trillion barrels. So what's stopping them doing this? They can't get enough CO2. Because logistics come into this. If you need CO2 available to you in commercial quantities delivered to your well site. The catch with the CO2 emissions that we're dealing with is some of it is very diffuse. It's been emitted from the tailpipes of all your cars individually. So the CO2 that's easiest to go after is the CO2 that's emitted at what we call point sources, large industrial sites like power stations, like natural gas processing plants, where there's a lot of CO2 emitted in one place. If we can get all that collected together, then that starts to make commercial sense to an oil company to inject it into an oil reservoir. Just to throw around a few more numbers in terms of emissions. Total emissions, these are slightly old numbers, 2004, but global emissions are about 27 billion tonnes of CO2. Of that, the US is responsible for 6 billion, China about 5 billion, Europe about 4 billion, and we're a minnow with about 32 million tonnes. A lot less than Australia here. On a per capita basis, who's causing the problem? It's actually not the Americans, nor is it the Chinese. On a per capita basis, it's the Middle Eastern countries that have very high CO2 emissions per head of population, and that comes about because of the oil refining and natural gas processing activities that happen in those countries. So most of the top 10 on per capita emissions is from the Middle East. New Zealand ranks about 50th on that table. So, point sources of CO2. In New Zealand, the biggest, my biggest target for a CO2 point source would be the Kapuni natural gas processing plant in Taranaki. What people don't know about that plant, unless you know where to look on the Ministry of Economic Development website, which means it's maybe a little hard to find, is that the gas that's produced at Kapuni is approximately 40% CO2. So Kapuni is a very important natural gas reserve for the country, but 40% of the gas that comes out of the ground is CO2, and that CO2 is vented at flare stacks at the Shell Todd plant. That is a point source that could be captured and injected underground. So are people doing this overseas? Yes. There's the first major project is called Sleipner and is in Norway. It was essentially done by the oil company for tax reasons. The Norwegian government imposed a tax on CO2 production from offshore oil and gas. The company responded in a very rational economic way and said, well, what's it going to cost for us to re-inject that CO2 underground? They've said, we do it all the time for enhancing oil production. We'll put it underground for tax reasons. Project's been technically successful, economically successful, and again, it's very heavily monitored by various European agencies to give the public confidence and trust that this idea could work. So that's been run by Statoil. They have 2 or 3 other major sequestration projects around the world. I'm working with the Western Australian government reviewing what will be the largest sequestration project, which is going to be operated by Chevron in collaboration with Shell. That's the Gorgon project. They are going to be injecting 3 million tonnes per year of CO2 under a place called Barrow Island. And Barrow Island is a very interesting place because it also happens to be a world-class nature reserve. There is unique flora and fauna on this island, so they cannot afford to get it wrong. So in the spirit of full disclosure, I am on the review panel working for the government to address some of the technical questions and try to give the government confidence that they should change the law to permit that project to proceed. It may not be as bad as it sounds because the island has operated natural gas facilities for many, many years successfully. Chevron go out of their way to avoid environmental damage. They spend far, far more on that project than they would have to in a different environment. They are very responsive to the needs of the island. So, if I just think about what volumes could the sequestration process achieve, the numbers are huge. There's an atlas produced in the US that says just injecting CO2 into old oil and gas reservoirs, that could handle 138 billion tonnes of CO2. So contrast that to annual emissions. So annual emissions, about 27 billion tonnes globally. We could deal with 138 billion by going into old oil reservoirs, deal with about 160 billion going into coal seams. The holy grail is going into these saline aquifers. They're very expansive, huge, huge formations. They reckon those formations could deal with 3,300 to 12,600 billion tonnes of CO2. So there is enormous volumes of pore space out there available that has the right geological properties to accommodate the CO2. So there are people who believe that the next hot property in terms of underground resources, you don't own what's in your backyard, by the way, below 10 metres or so. Everything below a certain depth is owned by the Crown. And if there's oil and gas under your house, the permit to exploit that is released by the government. And in some environments, the next sort of hot property may be permits for CO2 injection sites, not permits for oil and gas production sites. So I believe we have the volume and we have the technical capability to do this. What's the catch? Feels like there's got to be a catch. So the catch, just quickly, there's a technical issue that I am trying to understand heterogeneous, complicated 3D structures by essentially putting a needle in a haystack and using some other indirect measurements. So I'm dealing with something in the subsurface that I can't quite see, so I have to make inferences about a structure. There's the fact that CO2 is very corrosive. It will eat through pipelines. It will eat through the cement that holds the wellbores in place. So wellbores could become leakage pathways. Old wellbores left lying around, they may have been dead wells for 50 years, could become leakage pathways if they're not pulled apart and have special CO2 resistant cement put in. Economics, just quickly, money is the catch. So nothing comes for free. If I'm going to operate a power station that has a sequestration project associated with it, that's capturing the CO2 emitted by the power station, putting it back underground, the cost of doing that on an operational basis is going to be 15 to 25% more per annum. Why? Because to inject the CO2, I have to install compressors, I have to compress this gaseous CO2 into something that's much more like a liquid to get it efficiently into the pore spaces. So I need 15 to 25% more fuel to run my power station. So I've got to mine more coal or burn more gas. My power station is going to be more expensive to construct, so I could be looking at energy costs for a power station that runs this way of 30 to 60% more than what we have now. There's naturally issues over public perception of risk. That's completely understandable for something that's new, for something that's not well understood. But with the history that the oil industry is building up, there is very extensive review of these projects. So the latest study on this Weyburn project, where they're injecting CO2 for the purpose of displacing oil, has stated that there's a 1% chance of any form of leakage of CO2 from that site over a timescale of 5,000 years. So that's pretty good odds. The other sort of question, problem, grey zone in this is a legal question, the legal framework over who owns the CO2 and for how long. I don't expect Chevron will be in business in 1,000 years' time. So there is a legal question over when a company who has done a project like this eventually goes out of business, how does the liability transfer over to governments? Who takes ownership of the pore space at that stage.